average during the 20th century. Arctic summer sea ice declined by over 300,000 square miles, enough ice to cover the states of Texas and Kentucky. The vast majority of climate scientists say evidence for human-caused warming is clear. But less understood is exactly how this warming will change the complex interactions between our planet's land, water, sky, and the living organisms that inhabit our world. As NASA scientists improve their understanding and predictions about climate change, NASA satellites provide critical data about what's happening on our planet today, real-life observations scientists use to hone their predictions. And NASA gets a global view of three major pieces of the climate puzzle: how much of the sun's energy is hitting the Earth, how much of that energy is reflected back out into space, and how much is being trapped, heating the planet. NASA satellites measure the sun's energy, which fluctuates due to a 10 to 12-year cycle. Could increased solar activity be causing global warming? Satellite evidence shows us that the solar cycle has only a slight impact on our planet's temperatures. In fact, even though the last few years have been some of the warmest on record, the sun has been in a deep lull in activity. That means slightly less solar energy has been reaching Earth. And when the solar cycle ramps up again, scientists expect temperatures will rise even a little more. A second piece of the temperature puzzle is our planet's brightness. All other things being equal, a brighter, more reflective planet bounces more energy back to space. Some of the brightest, most reflective areas of our planet are those covered with ice. NASA imagery shows those areas shrinking, especially in the Arctic. As sea ice vanishes into darker ocean, our planet becomes less reflective and warms even further. Clouds also reflect a lot of sunlight. As our planet warms, more water evaporates, potentially creating more clouds. More cloud cover increases the Earth's brightness, possibly helping to cool the planet. But clouds, and the small particles called aerosols that help them form, are climate wildcards. Many current climate models predict some cooling due to increased cloud cover. Will it be enough to significantly slow warming? Scientists are using NASA data to look for the answer. Further complicating the issue is that water vapor is actually the world's most abundant greenhouse gas. That's right, the same molecules that might cool the planet in cloud form actually warm it when they're in the form. Satellite instruments capture the infrared signature of carbon dioxide in the global atmosphere. They show a rise. Greenhouse gas is most likely the main contributor to current global warming. It's the key piece of the temperature puzzle, and it's unlocked the door to higher and higher. What will the next 10 years hold for the Earth's climate? Computer models predict an even warmer planet.